Okay, so continue from where we left off in the previous lesson. We now have our particle simulation, and we're reapplying the transform. And we also have this group called new sim, which are the points that are going to be thrown into a new simulation so that they don't keep sliding along with the car. Because as you can see, since they have the transform, once the particles fall and are on the ground, they still keep moving with the car. Okay, and before doing anything else, I kind of want to fix, there's something I noticed, we have some points going through the glass in here. So whenever your collisions aren't accurate enough, it's as simple as just increasing your substeps. For example, we can change it to, let's see, something like 6. Let's go to the first frame. Okay, and as we can see now, this isn't going anymore. It's not falling through. The disadvantage of this is just that your sim is going to be a lot slower, but in this case, it's not affecting us that much. Anyways, let's go back up and let's start preparing for the new simulation. So the first thing I want to do is I want to get the release frame. Basically, I want to figure out what's the first frame that these points are turning red. So in order to do that, you'll see that over here, I left our old release frame. In this case, since we have new points, it's being overwritten. So I just want to make sure that we don't have it anymore. So I'm going to delete it and I'm going to create a new one. So for that, I'm going to copy the setup we already have. There's no need to recreate it again. So let's see. It's these 3 nodes. So I'm going to copy them and paste them over here. Okay. And then in here, we're going to be setting in again to the last frame plus 1. And then inside our solver, which is now going to run from maybe 10, let's say 44. Instead of getting now the emit frame, we're no longer going to do that. We're going to check if it's in the group. So we can just create an in group like that. And we're going to connect the first input in this case and the point number. And I'm going to call it new underscore sim. And that's going to be equal to 1. So let's change that. And then this one, instead of being the emit from the second input, is going to be the new sim from the second input. There we go. So just like that, and all this is okay. So we're still using the release frame. Okay, let's go back up. And let's go to the last frame. Okay, and now it's done. And as you can see, we now have our release frame. Now, there's some points that are like the first time this is running, although no point is being released in frame 1044, we have some of them being set there just because it's the first frame, so we're going to fix that. But before we fix that, you'll notice that with our time shift, we now killed the simulation. Basically, there's no, this isn't time dependent anymore. So what I'm going to do is I'm just going to do an attribute copy here. So, and we want to copy our new release frame. Just like that. So now our release frame actually works, right? And it's appearing whenever it's red. And to fix the one that it's set at 1044, since we know there's no particles there, we can just say if the release frame is equal to 1044, then I will say that the release frame is equal to 1148, just like that. It's never meant to be released. Okay, and then we're ready to copy the rest of our simulation, and we're ready to do another simulation. So for that, let's see, I'm going to copy the delete and the popnet and this other delete, and then the import, the clean, and the merge, well, and the sort as well. So all this we can copy and paste over here. Let's see, let's connect them here. And the other thing I want to set is, well, we won't change the mass anymore, but I want to change the friction and the bounce. So let's make sure we have this. And I think this is using the area, and we might not be having the area anymore. Let's see, I want to make sure that our clean over here isn't deleting our area. So let's do that. This is going to have to rerun. So let's get it to reset. Go now to the last frame. And now in here, our area should be working. Yeah, it is. So let's see, let's start with the mass. I'm going to remove that. Okay, so now we can move on to bounce and friction. So basically, everything that deals with mass, we're going to delete. We're just going to care about the bounce. Yeah, and the friction. Okay, so by default, I'm going to leave this the way it is. We're going to change it later on, depending on what we get on the simulation. The other thing we're going to need is that now that we are applying the motion back into our points, the velocity is changing because we're adding an extra motion based on that. So if we look now at the velocity, for example, right, these points aren't really going that way. It just looks like this because that's the velocity of the statics when we simulate from the static position. But if I add a point velocity and we calculate that again, we'll actually see that's the velocity we're getting. Okay, so it's very important that we have that velocity because we want the particle to inherit that motion and to then be dropped into the next simulation and to settle properly. So you might be wondering, like, what's the whole idea of working like this? Well, the nice thing is that although it's a bit more complex to set up and it requires a bit more of extra work, it's extremely fast to change the simulation. So you can go here, and the fact that it's static, it's extremely simple to sculpt your simulation. So if you need to have a bit more explosiveness or more pieces going in, more pieces going out, you don't have to worry about the car's velocity. You can see here, let's see, if we look at these velocities, this is so much simpler to work with. Like, you can tell all these are going to go outside, all these are going to go in. Now, when you're working with these ones, and they already have the car's motion, you have no idea if these ones are going to go like this side or these ones are going to go the other side. It just becomes a lot harder to properly art direct your effect. So in a shot like this, it can be pretty common to get notes that are like, okay, let's have 20% more pieces going outside. And you're going to have a really hard time finding what is the exact amplitude that or magnitude that the velocity should have so that it doesn't go as fast as the car, so it still looks like it's coming out. And if you have to make it explosive, like basically you're going to, you don't want to be tweaking parameters so much like to get a balance, because the moment you get another node, that's going to throw everything off. So this way we can just worry about getting it to look nice, and then we can apply the motion, and then we can make them settle. And nobody will know that we did it that way. It's going to look natural. Okay, so we have now our delete. So our particles are going to be going into the simulation as they fall. So we can probably start deleting the color. Let's see, so CD. So this is going to go into a new sim. Let's see, 1045. And we don't need any of these groups anymore, right? We just need our drag and our gravity. We don't need the ground plane anymore. We don't need a car anymore. So the next thing we need is the actual ground, because this time we do want the points to settle on this ground. So let's see, I'm going to actually object merge the ground, and we can copy that from a previous setup. So in this case, we want the road. Let's copy and paste this. Okay, and let's see what parts we actually want. Let's see, let's hide all the other objects. So I'm thinking maybe something like this. Okay, let's hit enter. That's going to now become our new ground. Let's make sure that we have a terrain object. And again, we can probably just copy this from here. So terrain object. Let's make sure we're using enough, let's see. Yeah, enough subdivisions. Okay, and let's hit play. Okay, and these particles, you'll notice that they're going extremely fast. So we'll probably want to, first of all, inherit a less of this velocity, like, I don't know, like a third, for example. So let's try again. Okay, so maybe that's too little. So let's see, let's go to maybe 0.4. Okay, and I'm going to let this run a bit more now so we can see the pieces actually settling. Yeah, and it seems that now they're falling, so we'll probably need to bring the actual wall in here as well. So let's see in what simulation we had that in the wall impact. So we have, that's our wall. Let's copy it, and we're going to copy the actual wall, which is, let's see, collision, wall geo. So let's bring that into our setup. So that's going to bring the collision geometry. Let's see, this is going to bring, I'm going to call this wall. So the name is a bit misleading. Okay, let's try again. Okay, now we can see these points aren't falling, but some of these are. I still think like these are sliding way too much. So one thing we can do is we can increase over here our friction. Let's see, we can try even 3. It was set to 2 already. Let's see, let's go into the camera view and let's see if we're going to actually see these particles fall. I think we won't really see them falling. But one thing I would really like to change is the fact that these particles aren't bouncing at all. And if you look at reference of windows breaking, these little pieces of glass, they end up bouncing so much. So let's see, I'm going to change this to like 0.9, for example. I really want them to bounce as they're falling. Yeah, something like that. Okay, and I'm going to go back out. And let's have a look at what all this looks with the actual glass pieces. So we're ready to bring our transform, which I left. Okay, I left it here. We can connect this just like that. Let's see, let's look at the actual transform pieces. So we can show all the car. Let's see how this looks, and this seems to be working. Okay, let's go back. And I'm going to do a flipbook of this. Okay, and that's how it looks. Awesome, I think it looks really cool. I think the bounce works nice, and it works very well with the camera as well, and the way the car is going. Before we finish with this effect, there's actually one more thing I wanted to change. That is, I noticed that if we look over here, when our pieces are starting to come out, I noticed that they all have the same orientation as the window. They're not rotating anymore, but over here they are. And that is because we left our orient over here from the previous setup. When we were doing it in a static way, we were setting them to 1 when they were still on the window, but we don't need that anymore. So it's important that you remember to delete that. And now it's going to work. So let's see, now we can go to shot camera and let's do another flipbook. And actually let's do it of the full frame range. Okay, and this is done, so let's have a look. Great, and that looks a lot better now. Now that our orientation is working, our pieces are going to look a lot better. So that's it for our glass breaking effect. In the remaining time that we have of this class, I'd like to copy this setup and reuse it for this car crash. So I'd like the windows of the enemy car to just shatter and explode the moment that it's hit by this car. So let's have a look at how we can reuse it and apply it on a different scenario. So let's see. I'm going to save this and let's go back up, and I'm going to copy this and paste it And maybe we can call it glass crash. Glass crash effects. Okay, and let's go inside and let's start setting up this part. So let's have a look. Let's go to the very beginning and let's ghost the other objects. So the first thing is I want to change this. I don't want the Range Rover. I want the enemy car. Like that. Okay, and then over here we were getting the transform. So we're doing that based on the windshield. So again, let's select that. See, oh, somewhere on the back. So I want to do that based on connected geometry. So the windshield, and I'm going to copy this and we can paste it over here. So you should have both the animated. There it is, the animated. And let's see now our frame. Let's see what our frame is going to be. Let's go a few frames before the actual car crash. Okay, so maybe this one, like one frame before. So let's say 11:08. So this is going to be our actual frame. And then I want to select over here what are the windows that we're going to be breaking. So let's see, 3D connectivity. I want to destroy that one, and that one. So these are the three that we're going to end up breaking. So let's see, let's do our remesh, the usual remesh. And then our noise. And let's see, I think this is fine the way it is. And now comes the Voronoi fracture. So this is going to be quite heavy. It's going to take a while. In this case, I don't want just 4,000 particles because that's what we had before for just 2 of them. So instead of doing this just in one go, I like to have a bit more control over this, and I like to do this over a for each loop. So we can say like for each connected piece, for example. And let's see, I think we can actually get a window attribute. So we be window 1, 2, and 3. So let's see, maybe up here, I'm going to move our connectivity. Okay, and I'm going to call this our window. It should be lowercase. Okay, and here I'm going to say for each window. And now when we connect this, we look at the result. We get one window at a time. So now we can scatter and fracture. But let's see, so now for the scatter, I don't want to have a fixed amount. So instead of doing that, I'm going to do it based on density. I want this one to have, for example, 4,000 points. So maybe that's a bit too much. Let's see, let's write 2,000. Okay, that's close. That's, yeah, almost 4,000. I would like to see what it is for the other windows. So we can see that if we go to single pass, okay, it's going to give us 800. And that's okay, that makes sense. So we're going to have about 6,000 pieces in total. Okay, so let's turn that off. And we can connect our Voronoi back in here. And it's going to cook for a while. And it looks like this is done. Let's connect this like that. And we need a bit more space. So let's see, let's move everything up. Just like that. And let's see, this is going to move everything back into place. And we can have a look at the exploded view. Yeah, I think that gives us a nice pattern. The other thing we can do is now we can bring back our window. Yeah, back to, let's see, let's bring it back. Let's promote it. In case we end up needing it, I'm going to promote it back to a point. So we'll say from primitive to point. And let's see, what else have we got? So we have our shard ID. There we go. We have, yeah, 5,600 of them. Okay, so we have our area. Let's see what this looks like. We visualize it on the color. Cool, that seems to be working. You can bypass it. Okay, our assemble. So maybe we want to keep our window, it might be useful. Next, we're keeping a point for every one of these debris. And now it's time to do the actual impact and where we want that to happen. So let's see. In this case, we have 3 different windows. And I think I want, basically when this car hits like this window to break and then the impact to propagate from here outwards. So the impact should be somewhere here. So let's see. Let's have a look at our window glass. And what we can do to turn this into just simple points is we can use an assemble. Right, we can create our own pack geometry. Let's see, we can transfer our window attribute just in case we end up needing it. And we can delete all this and have an add and have it to delete geometry but keep the points. Let's go back to the previous frame. So now we should end up with these 3 points. And I'm going to choose the point number of the first one. So let's see, that's 1. So you can blast this and say 1, delete non-selected. Okay, so that is going to become now our impact point. So we don't even need to ray it. Okay, that's now our impact. So let's go back here to our attribute transfer. And now I like to animate this. So I'm going to actually delete all the channels, turn it back to default. Let's go back to ghost other objects. Now let's have a look. So in this frame, we're not going to have anything. I think actually in this frame, so I'm going to set a keyframe that's going to be 0. And now this frame is where it's going to start to break. And I don't want it to be so small like the bullet hit. This is going to be like pretty fast. Like let's say over, I don't know, 2 frames. So it's going to be maybe 8 or 85. So that's going to be on the first frame. And then on the next frame, let's see, 1.5, 1.6. So just over 2 frames, all these pieces are going to be released like that. Okay, so now let's figure out our release frame. In this case, we don't have to start so early. We can tell it to start at 11:05, for example. Let's go to the end frame. Okay, and let's start getting our distance. So it's working. We're fitting our distance, and then we need to get some normals. So let's see, in this case, I think I want to get most of the normals, not just one, because if not, if we have just one polygon, this is going to be a lot closer to these points than this one will be. So to do that, I'm actually going to select, let's say I'm going to hide everything, and we don't want any of this. We don't want to select groups, and we want to select primitives. Okay, so I'm going to try to select something in the middle for each one of them, something like that. Okay, and then I'm going to use the row selection, and the hotkey is Shift G. So I'll keep pressing Shift G until it gets to a border. So for example, this one is in a border, so I'm going to just deselect it. Another thing we can do is we can change this to be a lasso peaking. It seems that our selection got lost. Okay, so let's do that again. And let's see, maybe to make this faster, we can select a couple of these guys. Okay. And we can maybe just deselect these windows and try again. Okay, Shift G. Okay, so now we can press enter, and that's going to be our actual selection. And let's transfer it. You can see some of them are kind of wrong, so let's go back. Selection. Let's actually shrink the selection, press enter. Can do it one more time. So shrink selection, enter. There we go. It seems that one is still giving us issues, so let's see, let's deselect it. There we go. Okay, let's do an attribute transfer, and let's make sure that all these are correct. Yeah, so now we've got the right normals. Now, unlike the previous example where we did this in a two-stage simulation, I want to do this just in one simulation. So in order to do that, I'm actually going to be reapplying the animation. So let's see, we have that down here. Okay. So that's going to be our first input. And let's see what this looks like. Let's start visualizing the velocity. And in order to do that, actually, we need point velocity as well. Let's see, let's move everything that's here. We need some space for whatever we're going to build now. So let's create a point velocity. Let's set it to compute the formation, okay. And let's make sure that these windows are working, actually, that they're moving with the car, and they are. Okay, so the next thing I want to do is I want to create our direction, and this is going to be similar to what we tried to do in the previous lesson. So let's go inside. Unlike the previous lesson, which we had this very involved setup, I'm not going to be doing any of this. I actually want to use the inherited velocity, because now that we're going to actually be using the animated particles, we need to make sure that we use that velocity. So let's see, I'm going to start deleting all these things that we're not going to need. And let's start working with like the very first just building block, which is going to be, I'm going to do a mix between our velocity and between our normal. And the bias is actually going to become our distance ramp, right? And then we have this normal direction amount. Okay, so now let's connect this into our final normalize. Let's go back up and let's look at the result. Okay, so if we go like that, if we go to 1, we're going to get mostly pointing towards the normal. And if we go to 0, we get the velocity. In this case, I want to invert our ramp, because I want whatever is furthest away to actually get the normal, and whatever is close, so in this case it's going to be, oh, let's go back. So this window, I want it to kind of go inwards. So let's see, maybe something like that. Let's see if we can add a bit more. I want them to be slightly more flat. Yeah, something like that. So I want these points to really go inwards, and then these ones, they can start to go upwards. Okay, let's go back in. Next, I would like to have some control over what is going up and what's going in. We're not really going to be using this anymore, the inwards and upwards. So let's see, we'll just have some noise. Going to kill all of this. Okay, let's keep moving this back. So you can see it's a lot simpler, our setup. Let's see, now I want a mix, and I want to control it with the up, but what I feel is going to happen with this, and it's the same problem we had before, is instead of having an up bias, I want to have like a down bias. So I want to push things downwards. So let's see, like 0, -1, 0. And this is going to become now our down bias. Just like that. Okay, and let's see. So in this case, I want to make sure that nothing is really shooting up like that. And let's see, let's take a look at our velocity bias next. So I don't want that much noise, I would say. I'd say something like this is fine. Maybe we can have a bit more roughness, so you know they all go in different directions. But I think something like this looks fine. You can see based on the offset that is going to work. Okay, and next we have our magnitude, and I can see already that since we're basically destroying the magnitude of our velocity, it's important that we save it. So I'm going to click there on calculate speed. And I think everything we're doing here is fine. We're just having some noise. The amplitude, we're mixing it with the distance as a bias. And then we're setting our minimum and maximum. I just think I'm going to bind over here our speed. And let's connect it. Okay, and instead of having here our minimum speed set to 0, with values about 0 and 1, I want to make sure that our maximum speed is going to be 1, so we don't go faster than the inherited speed, and maybe the slowest might be like 0.5. Now let's have a look. So you can see there's still a bunch of things going upwards, but we might have to push everything down even more. Okay, and then over here we have, let's go full screen. So we have our mass, bounce, friction, and orient. And then we have these two deletes. And now instead of dealing, because this was our static simulation, we're not going to be using this anymore. I want to go directly to this last simulation where we were using basically we're colliding it against the ground and everything was settling. Okay, we can do it this way. So now we're going to delete. We're reading our road. We probably don't need the wall anymore. I doubt it's visible at this point. We can get rid of the wall. Okay, and let's have a look at what this looks like. Also, let's change the start frame to maybe 11:05. And there's a few things I'd like to change in this popnet, and that is, I think we ended up, no, so we have only 2 substeps, so that's okay. Let's inherit velocity. Let's start with 1. Let's turn this off, and I think we're ready. Let's go into the shot camera and let's show all the objects and let's hit play. Cool, and that's looking pretty good. Let's see. I think maybe there's something that it's not really playing real time, so let's do a flipbook. Let's play it. Okay, and I think it might be going way too, let's see, way too far. So let's use a little bit less velocity, like say 0.9. Let's reset it and let's try again. See, let's hit play again. Okay, this is starting to look a lot better. One thing I'm noticing is that our collision doesn't include all that space. So yeah, we need to, let's see, go back. Let's work on fixing that. So we're going to need, in this case, the collision of the road plus the roadside. And again, we did that in a previous setup, so we can just copy that. I think it was on the car crash over here. So that's our ground. Let's copy. Let's paste it. Like that. And let's see, let's start selecting this. So I'm going to hide the other objects. Let's go back to auto update. And let's select this. Okay, maybe we need to see a little bit. That's actually good. What about this one? yeah, so this is actually exactly the ground we need. Let's make sure that the terrain object has enough samples, and it does. Let's hit play again. Cool. Okay, now the ground is working. Let's have another look at this, and we can start probably just visualizing the actual pieces. And actually, before doing that, let's go back and let's delete from the display of the car. Let's delete those three classes. So that's the enemy car. I'm going to create a blast. Let's go back to auto update. Select it. Let's see, let's hide all the other objects. There we go. And I want to select groups or connected geometry. So we want to that, and that. So let's press enter. Okay, and now we can go back to our effects. Let's see, let's show everything. Let's go back into flat shaded mode, and now let's do a flipbook. Okay, and this is done. Okay, so that's looking really good. So that's it for this effect. The last thing we're missing to do is now to look at all of these together and see what the final result of our course looks like. Before we actually have a look at the final result, I just wanted to show something that I did for the class. So I created an object merge, and I brought in the original window, which is here, and we want the animated one, right? So that one. So for some reason, since it's unpacked, it has that bluish color, but when we pack it, it has the same color. So I'm just packing it. And here I have a switch because we don't want everything to look cracked until the previous frame. So basically here I'm just saying if the frame is greater than 1046, then switch to our cracked pieces. And you can see in this frame, we have our original glass. In this one, it cracks. And then in the next one, it actually breaks. So anyways, let's have a look at the final result. And here it is. These are our 3 shots with all the effects complete. So this brings us to the end of this course. I hope that you have enjoyed it, and I hope that you learned a lot about particles and that you had fun with these shots. I would encourage you to keep going with this sequence. Try to add any other things that you can think of. There's definitely a lot more that you can add. I hope that you had fun with this lesson, and I'll see you the next time.